Math Stuff by Anna and Tim, featuring inverse functions.
Alright, in the original function, you have x and y, and x is the independent variable, and y is the dependent variable. So when you plug in -3 for x, you get -2 for y. And in the inverse function, when you plug in -2 for x, you get -3. So that means the x and y switch. So y in the inverse function is the independent variable, and x is the dependent variable.
This is the original function. To solve for the inverse, you take the y and switch it to an x, and then you take the x and switch it to a y. Then you solve. So you add the 10 over to the other side, and then you divide by -3 to get your answer, which is y equals x plus 10 divided by -3. Then you put it into inverse notation, which is f to the -1 of x equals x plus 10 over -3 right here. And then that's it.
Alright, in this example, the original equation is f of x is equal to 3x plus 4 all over 7. So what you want to do first is make f of x y. Then you want to switch the x and the y right there. Then you want to start solving for y. So you want to multiply by 7 on both sides. Then subtract by 4 on both sides. You have 7x minus 4 is equal to 3y. Then you divide by 3 on both sides. And you have y is equal to 7x minus 4 over 3. Then, to get into inverse notation, you want to write it as f to the -1 of x, which is equal to 7x minus 4 all over 3. That's right there.
In this problem, you are trying to figure out if g of x is the inverse of f of x. So, you do the same thing, so solve for f of x, so change the y to an x, and change the x to a y, and then start solving. So multiply by 4, and then add 16 to both sides. And so the inverse of f of x right here is 4x plus 16, which is g of x. And so g of x equals the inverse of f of f to the -1 of x.
The end.